Hi everyone, my name is Justin and this is my fellow colleagues. We have Ariel, Maria, and Peter, and we're here to bring you about the Hyatt Regency Hotel, which had a tragedy happening in 1981. It was the day of 17th July at this hotel right here. There are two things that were supposed to have that happened actually. We had the tea party dancing going on, and then later on we had a tragedy where over 100 people died and 200 more were injured. The construction of this building began in 1978. It was a 40-story building, and despite the setbacks in its construction, the building was able to open the doors in 1980. With that, I will leave the details with Mariah about the structure of this building and how cool it was before it turned into a tragedy.
Alright, so that's a picture of the lobby with the two walkways. That's the fourth and the second story, and that's the third story. So the fourth floor walkway was directly above the second story. During construction, they found a flaw which made the contractors change the design, which resulted in double loading of the connection between the fourth floor bridge and the atrium roof. So it critically undermined the safety of the structures, and the rod connecting the fourth floor walkway was double loaded and holding the weight of the second story and the fourth story. And so the design of the walkways were steel, glass, and concrete construction walkways. They connected the second, third, and fourth walkways from north to south. The fourth level walkway was directly above the second, and each walkway was 37 meters long and weighed about 29,000 kilograms. So this is just another picture of the walkways. So the rods that were holding up the fourth floor ones were holding up the weight of both of these. So when too many people were on the second story, it kind of just collapsed.
And we'll have Peter to walk you through the disastrous day and how rigorous the rescue process was.
Now, on the day of the disaster, there were 1,600 people in the lobby, and at 7 p.m., there were 40 people on the second level walkway, and 15 to 20 people on the third and fourth level walkways. Now, the connections between the fourth floor walkway and the atrium roof failed, and the rescue team said it looked like a war zone. Here we have an image of the walkway collapsed. And the rescue operation was 14 hours long, and there were 60 tons of concrete, steel, and glass over the victims. And it was extremely hard to move this debris. It was very heavy, and the operation required cranes to move that debris because other machinery wasn't capable of doing so. And it was so hard to move the debris that some victims had to have their limbs amputated to get out of that. Some more images of the collapse. You can see there's some forklifts, but the forklifts weren't even able to move the debris. And on top of this, the sprinkler system failed and poured water into the atrium all along when this happened. And it was impossible to shut off, and many victims almost drowned because there was so much water in the atrium. And to prevent any fires, the power supply of the building was shut off. I'm gonna hand it over to my friend Ariel to finish it off.
Okay, so what went wrong physically with the design of the walkways was these are box girders, and these are what are supporting the walkways. So, and they're tied together with hanging rods. So right here you see this is the original design, and basically what it boils down to is that each of these box girders are supported individually, so they could move individually. But when they changed it, now the fourth floor walkway is also supporting the weight of the second floor walkway. So now it's double the load, and the engineer didn't account for that this would be way too much weight for the fourth floor walkway to have, rather than just one walkway. So now I'm going to show you guys a full visual to further show what I'm talking about.
Today's guest video is from Grady at Practical Engineering. He's talking about a tragedy and the lessons we learned and the reasons why it happened.
Since the original design, the load of the two walkways is independently transferred to the hanger rods. Notice how I can lift each girder without affecting the other. Now let's look at the design change. In this configuration, notice that the entire weight of the second floor walkway is being borne not directly by the hanger rod, but instead by the girder above. If I lift the fourth floor walkway, the second floor walkway is lifted as well. The hanger rods are still carrying the same load at the top, but the two nuts on the upper girder are supporting the weight of both walkways. This simple change effectively doubled the load on those bolted connections. Imagine that.
Okay. So in conclusion, the Hyatt Regency collapse is one of the biggest engineering disasters in American history. And this was all due to just one subtle mistake that was overlooked by the engineer. So, in essence, you should always check when your calculations. You should check your calculations when you make a change to your design. Otherwise, something so small as changing where the hanger rods are could destroy your entire construction and kill several people.